Natural numbers are also.
I'm hoping that you all might write the answer.
Positive 7,214.
Hey guys, welcome back to the Mist of Knowledge, and today there will be a new chapter of maths. So as I didn't take the chapters and learnings for so many days, I thought to take you guys a lesson of maths in a row. So there won't be any parts like this as the earlier one. You might get the whole chapter in one whole episode. So why don't we just go to the chapter? So today we'll be learning the second chapter because we finished the last chapter, the first chapter, and the name of our second chapter is Natural Numbers and Whole Numbers. Just like the topic says, natural numbers and whole numbers. So what are these natural numbers and whole numbers? Let's see. Let's learn what are natural numbers. The numbers 1, 2, 3, 4, and so on are called counting numbers. Counting of these numbers comes naturally to us. Therefore, mathematicians also call these numbers natural numbers. Hence the number 1, 2, 3, 0, 1,000, not 0, are called natural or counting numbers. So the main thing that you have to think about these numbers are the numbers like 1, 2, 3, 4, 5, and so on, but not included zeros. So the number system that does not include zero, or the numbers that we can count, are called natural numbers or counting numbers. So you can remember a point that natural numbers and another name of natural numbers are counting numbers. So what are the successor and the predecessor of natural numbers? So in the successor and the predecessor, if anyone gives you a number 1, then that is the first number starting in the natural numbers. So the successor of 3 is 4, and successor of 2, predecessor of 2 is 1. So that's an easy thing because successor means always add 1, and predecessor means always minus or subtract 1. All natural numbers except 1 have both successor and predecessor. Keep this point in mind. So the next thing is whole numbers. So before we begin whole numbers, this chapter is mainly about whole numbers and properties. So let's listen. Whole numbers. All natural numbers along 0 are called whole numbers. Every natural number is a whole number, but on the other hand, there exists a whole number 0 which is not a natural number. Thus, a whole number 1 has the predecessor 0. So this is whole numbers. As I said, in the natural numbers, all the number system except it excluded 0, and in the whole numbers 0 is included. That's just the difference. So I hope you understood the difference between the whole numbers and the natural numbers. If you want to listen to more and more of these, like repeated times to understand them properly, just go back the video and play it again. That's how you can understand if you didn't get the points. Next thing is the addition of whole numbers on a number line. So I know you guys already know what is a number line. We've been studying those from our grade 1st, and it's obvious we know because we reached in grade 6th. So my dear friends, it's not a big deal because we already know how to do addition. So the main thing is that when you do addition on a number line from whole numbers, the counting should start from 0. Got that? So if I say add 3 plus 5 on a number line, so the main thing that you should do is first from 0 you have to jump 3 times, like 1, 2, 3, and then again jump 5 times, 1, 2, 3, 4, 5, and you might get the answer 8. That's a simple thing. I don't have to explain it like 1,000 times or anything, because it's obvious, you know. Same goes with the subtraction. So now there goes the properties of whole numbers. So this is the main point. So my dear friends and all the viewers who are watching this video, you have to keep in mind that whenever you learn mathematics, the main point is to learn the properties of addition, subtraction, multiplication, and division. So let's start with addition. So in addition, there are 5 properties, which goes closure property, commutative property, associative property, existence of additive identity, additive inverse. So let's start. Closure property. The sum of 2 whole numbers is always a whole number. For example, A and B are 2 whole numbers, so A plus B is equal to a whole number, which means 5 and 3 are 2 whole numbers. So 5 plus 3 is equal to 8, which is in turn a whole number. And then is the commutative property. The sum of 2 whole numbers remains the same, irrespective of the order in which they are added. For example, A and B are 2 whole numbers, then A plus B is equal to B plus A. There won't be. So this commutative property says that even though two whole numbers are exchanged while they're additions, for example, if there is a 7 and a 1, so we're writing 7 plus 1, we get 8. But there is no difference with the answer because 1 plus 7 is also equal to 8. So the answer is always a whole number and never changes. The next thing is the associative property. You might heard of this. So the sum of the whole numbers remain the same even if their grouping is changed. So we learned about the grouping. I think we didn't, but still we will learn, and don't worry. The grouping is a simple thing that just tells about the bracket. So for example, A plus B plus C. In that, A and B are in the brackets. For example, A plus B plus C, I'll give an example as 3 plus 2 plus 1. So if 3 and 2 are in the bracket, first we'll find the answer to 3 plus 2. Then the answer would be, so the answer will be 5. And then we add 1 to the 5. Then we get the answer 6. So even if the grouping is changed, for example, we are doing 3 plus 2 plus 1, and 2 and 1 are in the brackets. So first we'll add 2 and 1, which is equal to 3, and then we add again 3, then we get the answer 6. So this associative property is a very simple thing that you can understand very easily. And next is the existence of additive identity. So if anyone asks you what is the additive identity, then you have to say it is 0. Well, it actually means if we add any number to 0, we get the same answer. Then it is called the additive identity. The next one is the additive inverse. So I'll just read this paragraph for you. If A plus B is equal to 0, then we say that B is the additive inverse of A and A is the additive inverse of B. Since for any given whole number A, there is no whole number B such that A plus B is equal to 0, the additive inverse of whole numbers does not exist. For example, 7 is a whole number and 7 plus negative 7 is equal to 0, but negative 7 is a whole number. So this says that if two whole numbers add together, then we'll get the answer properly, and it means it will get the answer 0. So it means that there is an additive inverse. For example, we write for example, it is 6 plus 0, then we get the answer 6. So it is not there does not come an additive inverse, but still there's something. 6 is the additive inverse of 0, and 0 is the additive inverse of 6. But in case if, even though the number is, there is a number and it is not a whole number, for example, like the example given here, -7. So if there is something like this that is not a whole number, then there is no existence of additive inverse. Let's go to our next subject. It is subtraction. I just said it's subject as it is a part of the mathematics. So the closure property. The closure property is also present in the subtraction, but it is not closed, which means because A and B are two whole numbers, then A should be greater than B so that A can subtract B. But if B is a smaller number, then B can subtract A. So it is not closed under the closure property. For example, 6 minus 2 is equal to 4, but 2 minus 6 is equal to -4, so it is not a whole number. The next thing is commutative property. As we said, if two numbers add each other, and if we even change, it will be equal. So in the subtraction, it's not possible because if the numbers are same, then it is possible. But if there are different numbers and then you're trying to do a commutative property, then it's not gonna work because there will be a little bit variations. Like I said, here it is 6 minus 2, then we get 4. But if we minus 2 minus 6, then we get a negative number, which is not a whole number. And then comes the associative property. Let A, B, C be three whole numbers, then bracket A minus B minus C is not equal to C minus C, A minus B minus C in the brackets. To say it simply, it's just like the closure property and the commutative property. There is no associative property. For the example I took earlier, if 3 minus 2 minus 1 and 3 and 2 are in the brackets, so 3 minus 2 is equal to 1 and 1 minus 1 is equal to 0. But we can't minus, but there will be a different answer and it is not going to be same if we do 3 minus 2 minus 1. So if we do 2 minus 1 is in the bracket and 2 minus 1 is equal to 1, and we minus 3 minus 1, which gets the answer 2. So there are two different answers. One was 0 and the other was 2. And the next is the property of 0. So in here, the 0 is a property because if we subtract any number to 0, then we get the same answer. Okay, so let's check the next page. Here's a point. I'll read it for you. Let A, B, and C three whole numbers such that A minus B is equal to C, then A is equal to B plus C. For example, 7 minus 3 is equal to 4, then 7 is equal to 3 plus 4. If we add the last two numbers, which we minus from the greater number, then we get the correct answer. It's a simple thing you might understand while just seeing it or reading it. So let's go to multiplication, and in the multiplication there are the closure property, the commutative property, the associative property, existence of multiplicative identity, multiplicative inverse, property of zero, distributive property of multiplication over addition. It's almost same to addition, but there is something more. Let's read it. The closure property. The product of two whole numbers is always a whole number. Well, if A and B are two whole numbers, then the product will be a whole number. Like if 7 multiplied by 2 is equal to 14, and 7 and 2 are whole numbers, while 14 is also a whole number. And the commutative property, even though if we change the two numbers that we are multiplying, we will get the product the same answer. Like the example given here, 5 multiplied by 3 is equal to 15, and 3 multiplied by 5 is also equal to 15. Then we go to the associative property. It's just like the addition. Even though if we use brackets to multiply, the answer will be same. If you didn't understand this way, then go back and listen to the addition properly, and then you might understand how this works. But just to give you a tip, I'll give you an example. Here's an example. 2 multiplied by 3 multiplied by 4 is equal to 6. 6 multiplied by 2 is equal to 24. And this makes something, like 2 multiplied by 3 is equal to 6. And 6 multiplied by 4 is equal to 24. Even though the directions are changed, for example, 3 multiplied by 4, we get it here as the answer 12. And then we multiply 2 multiplied by 12, and we get the answer 24. See, this is the way how you do it. The next thing is the existence of multiplicative identity. When a whole number is multiplied by 1, we get the same number. For example, A multiplied by 1 is equal to 1, or A. So here we get something like this. For example, if we are multiplying a number like 10, 10 multiplied by 1 is equal to 10, and 1 multiplied by 10 is equal to 10. So this means if we multiply any number by 1, then we'll get the answer 10. So the multiplicative identity of multiplication is simple. It's 1. So, if I ask you a question, what do you answer? What is the additive identity? I'll give you like 10 seconds. I can count right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hope you got the answer. Yeah, the answer is 0. So, let's go to the next one, which is the multiplicative inverse. For example, if A into B, or multiplied by B, is equal to 1, then we say that the B is the multiplicative inverse of A, and A is the multiplicative inverse of B. But if A multiplied any fraction like 1 by A is equal to 1, then the multiplication of whole numbers does not exist. Let's go to the 0. Property of 0. Let's go to the next property. Property of 0. See, in here you might understand it very well that if we multiply any number by 0, we get the answer 0. So that's not a big deal because you already know this from your little grades like first standard. Yeah, you guys are just like me. So the next one is the distributive property of multiplication over addition. This thing is not so complicated, and I know that you guys can understand it very well. You all know that multiplication and addition are almost the same. So if we multiply 4 multiplied by here we have a number. 4 multiplied by bracket 5 plus 7 is equal to 4 multiplied by 5 plus 4 multiplied by 7. See, this is not so complicated. So, and I say that, you might think I have been saying this like so much times. I'll give you an easier number, like 3 multiplied by 2 plus 1. So when you give the answer 3 multiplied by bracket 2 plus 1, then we get the answer 2 plus 1 is equal to 3, which is 3 multiplied by 3 is equal to 9. An easier way is 3 multiplied by 2, 3 multiplied by 2 plus 3 multiplied by 1, which can also give us the answer. 3 multiplied by 2 is equal to 6, plus 3 multiplied by 1, 3, which equally gives us the answer 9. So that is the distributive property of multiplication over addition. These are a lot of works, but you don't have to check all those, because I'm already going to give you questions after this lesson. So I would want you to answer all the answers in 10 seconds or maybe more. But one thing is there, the questions will be really simple, and I'm hoping that you all might write the answer. Or you can take the copy of these questions so that you might get to learn during your exam times. Or maybe you can just go on back over and recheck the chapter, so that if you have any doubt on any questions, you might get the correct answer. So let's go to our next property of division, closure property. So, as I said, the division is a not closed on closure property, just like the subtraction. Because if we divide 22 divided by 5, then it makes 22 on the top. So which makes 22 on the top and gives us a wrong fraction. So it's obvious that there should be a smaller number dividing a larger number. So B here, like A and B are any two whole numbers, and B is not equal to 0, and A divided B is not necessarily a whole number. These whole numbers are not closed under division. And the commutative property, let A and B be two non-zero whole numbers, then A divided by B is not equal to B divided by A. Thus, whole numbers are not commutative under division. For example, 8 divided by 2 is equal to 4, but 2 divided by 8 is not a whole number. It gives us a negative 4. So let's go to the next property, which is the associative property. Let A and B and C be three whole numbers where Let A, B, and C be three whole numbers where B is not equal to 0 and C is not equal to 0. Then A divided by B divided by C is not equal to A divided by B divided by C, which is a different type of bracket. You just have to think that division is just like the subtraction, which does not have any closure, commutative, or associative property. That's it. We have finished our second chapter. So I see a division algorithm over here. So this thing is not much important because you might already know the division algorithm is just telling us, just to give us a strong confidence that our answer is correct. For example, 14 is the divisor, 3 is the quotient, 4 is the remainder. I think we learned this like from when we were very little. So it is like this. Dividend is equal to quotient multiplied by divisor plus remainder. So that is the answer, and patterns are the easiest thing that you can learn, so I don't think I have to tell you those. And our next chapter is going to be the negative numbers and integers. But before we start, I need you to answer some questions of the second chapter.
It's time for questions. Natural numbers are also called dash. Answer countable numbers. Two. In the properties of addition, which number is the additive identity? Answer 0. Three. Division is not closed on closure property. True or false? Answer true. Four. 1 is the multiplicative identity of a number. True or false? Answer true. Five. Subtraction is dash under the commutative property. A. Closed. B. Not closed. Answer B. Not closed. Six. Closure property is not closed under A. Addition, B. Subtraction, C. Multiplication, and D. Division. You can choose more than one option in this question. The answer is option B and option D. 7. 7 minus 3 is equal to 4, which is equal to 3 minus 7. True or false? Answer: false. 8. Bracket 7 plus 1 plus 2 is equal to 10, which is equal to 7 plus bracket 2 plus 1. Is it true or false? Answer: true. 9. Bracket 5 minus 2 minus 1 is not equal to 5 minus bracket 2 minus 1. Is it true or false? Answer: true. 10. Bracket 4 plus 2 plus 1 is not equal to 4 plus bracket 2 plus 1. True or false? Answer: false.
So guys, how was your questions? Were they easy or were they a bit tough? If you feel them a bit tough, go back, listen to the parts which you felt it tough, and then revise it. Then come back here and listen to this chapter. So negative numbers and integers. While I say negative numbers, you might get the answer as these numbers are negative and always have a minus symbol for them. But they are in. So when these negative numbers and whole numbers join together, they form a number line or a formation of number line called the integers. So in the integers, the whole numbers are always at the right side and the negative numbers are always on the left side. So let's see, there's an integer number here. -4, -3, -2, -1, 0, 1, 2, 3, 4 are integers. The numbers -4, -3, -2, and -1 are called negative integers, while the numbers 1, 2, 3, 4 are called the positive integers. The number 0 is an integer which is neither positive nor negative. So you might get the answer right here that the numbers to the left side which has negative symbol, and they are called the negative integers, and the numbers which are on the right side are the good guys, and which are always on the right side is called the positive integers. Well, we see a 0 over here, which is a calm and quiet number which is not there for a neither positive or negative things. It's just a normal integer. So, do you know how to represent integers on a number line? So, for example, if you draw a number line and mark 11 lines, then in the middle, like 1, 2, 3, 4, 5, 6. The sixth line you put a 0, and on the top you put O. Then you write here on the positive side 1, 2, 3, 4, 5, and so on. And then on the negative side, or the negative numbers like -1, -2, -3, -4, and -5. So that's how you write integers on a number line. So, do you know how to order integers on a number line? So, if anyone says, if there is something like, if anyone is asking you what the temperature is below 0 degrees Celsius, then what do you say? As it goes below and it goes as a negative sign and says something that goes downwards and negatively, you might think it's some part like a negative motion, and those goes with the negative numbers. I hate saying negative, I want something positive. So if anyone's saying the temperature is above 0 degrees Celsius, then there is something positive going on here, something that says above going further, which means it always lies on the positive side. So you might get the answer to that thing because it is something that is very easy. So I don't think I have much to tell you in this chapter because here it is the simplest chapter in our textbook, because integers are some simple things which only tell us about the negative, positive, and the 0, and then form an integer. But do you know what is an absolute value of an integer? If someone gives you like this, if anyone is giving you bars after putting a negative number, then the answer would be the positive number. Even though if the number is a positive number inside the bar, the answer would be a positive number. But if a negative sign is outside the bar and the negative number is inside the bar, then the answer would be negative. See, just to make you sure, something like this. The absolute value of a positive integer is the number itself. The absolute value of 0 is 0. The absolute value of a negative integer is always greater than the number. For example, the absolute value of -56 is equal to -56 inside a bar is equal to 56, which is greater than -56. So as I reached here, I thought to tell you, if anyone asks you which number is the greatest, is it -2 or +2? What would you choose from these two numbers? Would you choose -2 as the largest number or the +2? As I always say, and I always remember that anything that is on the positive side is always the greatest. And even though if you know the predecessor and the successor, which we will be learning further over here, so I just don't want to take it before I say it. And like that, if someone asks you like that, what would be the predecessor of 3? The predecessor of 3 is 2. We're just minusing or subtracting 1. So the predecessor of 2, negative 2, is 3. We're just going backwards. We're going to the negative side. We're going really negative. So if negative 1 and negative 2 is there, negative 2 is the greatest negative one, and the negative 1 is a bit of positive mixed in it. Well, it is the greatest number from negative 2. So you just have to think that, and the successor would be negative 5. What is the successor of negative 4? It is negative 3. You may think, what? How can that be? But as I said in the predecessor, you might get the answer very simply that it is negative 3. But in the positive side, if I ask what is the successor of 3, then the answer would be 4. Please don't get confused. If you didn't understand it, please go back the video and listen to like 5 times. Then keep it in mind and remember the points. So here we have the operations on integers, which calls the addition, subtraction of integers. So first we'll be adding and learning the addition of integers. So while we add, positive plus positive is equal to positive, negative plus negative is equal to negative, while positive plus negative, just put the number and put the sign of the greater number. For example, negative 2 plus negative 3 is equal to negative 5. 2 plus 3 is equal to 5. Negative 2 plus positive 3, then the answer is equal to positive 5, as the symbol of the largest number, which is 3, is positive. Okay. So if anyone gives you a question, you might get the answer very easily, and you have to learn how to do it on a number line, as it said. If anyone asks you about positive, then it's positive, and negative, it's negative. And if anyone asks you positive, negative, then as I told you, you should always follow the rules. Then let's go to the subtraction of integers. But before I go, I'm repeating this like so many times so that you might get a remembrance of the thing that you have remembered. Please, if you haven't understand, just go back up the video and then listen to it very carefully. Keep your heart attached to the knowledge. Then understand it very well inside your heart. Then you might not even have to learn it like by heart. You might just get it in your mind. It might pop up in your mind. So let's go to the subtraction of integers. So when we say the subtraction, if anyone gives you, for example, like a negative 3 minus negative 2, what would you give the answer? For example, if just take that question and then do it as change the negative symbol. Do you know why? Because there is no subtraction in integers. We just have to change the subtraction symbol. And while you change it, for example, if anyone's giving you a question like 2 minus 7, and think as I gave it negative. So when I say 2 minus 7, you have to think one thing, that when you change this minus symbol and when you make it into like a plus, you should change here into negative. Do you know why? That's one of the rules. I don't know why. you have to change both of these symbols over here. Even though if there's no symbol, but you have to put a symbol, and then you have to do the followings. Like do the additions how you have learned. For example, like the positive is equal to positive, negative is equal to negative positive. Write the answer by adding it, and then put the symbol of the greatest number. Sometimes they might give you the questions by putting it into the absolute value, like in the brackets. So that thing is not a big deal. And then we go with the subtraction of integers on a number line. As just like the addition of integers, subtraction is also very easy. I don't think I have to tell or explain it like a lot of times, but there is a thing that I want to say. We're learning all these things in mathematics so that we can understand everything in future. Even though it might be a little bit hard right now, doesn't matter. We have to give our hearts towards math. Not all people, not even me, can also always be a great person in math. But we should learn how to be. Even I am trying how to be a great person, how to achieve great marks, great achievements in math. Well, I think math is something that we need in future other than anything else. Of course, science and all are needed, science, socials, but before that, you need something that can give you calculation, that can help you achieve your dreams in the future world, even if you're studying science. There is something that you have to calculate. Even though how hard you feel, don't worry. Keep your mind, then learn it. And if you didn't get it properly, I'm repeating it again, that go back the video, repeat the question like 5 times. Then I gave some questions earlier, don't you remember? Yes? Just go and check those questions and try to answer it again. Then there will be a next question on the 3rd chapter about integers and negative numbers. Don't worry, it's not gonna be so hard. I hope you liked this video and hope you understood.
Are you ready for another round of questions? Here we go! 1. A set of numbers including whole numbers and negative numbers are called dash. Answer: integers. Two. Dash symbol is used to represent a negative number. Answer: subtraction symbol minus. 3. -4 plus -2 is equal to dash. Answer: 6. 4. +4 plus +6 is equal to dash. Answer 10. 5. Positive 10 plus negative 8 is equal to dash. Answer 8. Explanation. Positive 10 plus negative 8 is equal to 10 plus 8, 18. 10 is greater than 8, therefore 10 is a positive number. 6. Negative 20 minus positive 15. Answer negative 35. 7. The absolute value of negative 9 inside the bracket is negative 9. True or false? Answer false. 23 inside the bracket is equal to Answer negative 23. 9. Negative 445 inside the bracket is equal to Answer positive 445. 10. Positive 7,214 inside the bracket is equal to dash. Answer positive 7,214. What do we do when we get bigger problems? Let us learn some of them with a few questions and answers. 1. Brittany, Jeanette, and Eleanor are sisters. In their school cheerleading, there are 24 cheerleaders, including them. There are 64 pom-poms where each student has to take 2 pom-poms. How many pom-poms are used? In this question, Brittany, Jeanette, and Eleanor, they are 3 sisters. In their school cheerleading competition, there are 24 cheerleaders and they have 64 pom-poms, in which each student has to take 2 pom-poms. So, if they're taking 2 pom-poms, how many pom-poms are used by 24 students? Answer. Number of cheerleaders is equal to 24. Number of pom-poms is equal to 64. Number of pom-poms used by each student is equal to 2. Total number of pom-poms used is equal to 24 multiplied by 2 is equal to 48. Therefore, 48 pom-poms were used. This answer tells us that 24 cheerleaders used 2 pom-poms each. So, if we want to get the answer, we should multiply 24 with 2. And when we do that, we get the answer 48. Thus, we could simply answer 48 pom-poms were used by 24 cheerleaders. 2. Alvin, Simon, and Theodore have bought 9 packets of sweets. How many packets will each person get? This question asks us that Simon, Alvin, and Theodore, they bought 9 packets of sweets. So, from these 9 packets of sweets, how many packets will each person get? Number of packets bought 9. Number of people 3. Number of packets received by each person 9 divided by 3 is equal to 3. Therefore, each person got 3 packets of sweets. This answer can explain you that the number of packets were bought 9 and the number of people were there were Alvin, Simon, and Theodore, so there were only 3 people. And the number of packets received by each person, which is the answer we need. So here we need to divide 9 by 3. Then we get the answer 3. Therefore, each person got 3 packets of sweets. 3. A whale dived to the depth of 100 meters below the sea. State the integer. This question asks us that a whale dived 100 meters below the sea. So, as depth came, it means below or downwards. And it tells us to state the integer. It means to state the number which is present in the question with negative or positive symbols. The answer is negative 100 as it states the depth of the sea. This indicates that the depth of the sea which the whale has gone below was 100 meters, and in turn, as the word says depth and shows a negative representation, therefore the number got its symbol as a negative 100. Another way is to just check whether the sentence is telling a negative side or a positive side. So it is going to be very easy to understand the answer and state the numbers. So hope you have understood all the questions and the answers. So hope you have liked our video, and if you did, then don't forget to click the like button. And then if you want to get more informations like maybe Teacher's Day or Republic Day speeches or so many things and so many rules and regulations or maybe pronunciation tips, you might want to know most of these like this, or maybe you want to know how to speak English if you're a beginner. Well, if you want to know all of this, why don't you go and click on that subscribe button and click on our channel, then go and scroll over and click on the video that you want. Then all you gotta do is click on the bell icon if you want to get more information or more videos that I will upload. So stay connected, guys, and bye. And another information, stay safe and stay home. Signing out, Mist of Knowledge.